All right, hi everyone. It's very nice to be here with you today. My name is Joseph Bonais. I am a Principal Cloud Solutions Engineer at Confluent, and it is my pleasure to own the technical partner relationship with between AWS and Confluent. So joining me here today is Kai and Brian. Why don't you guys introduce yourselves to the group?
Yeah, Joseph, great to be here. My name is Kai. I'm based in Germany, and I also live in the Lufthansa lounge, so I travel a lot to customers around the world. I work with many telcos in Asia, in EMEA, and in the US, like here with Dish today, and I'm happy to share the insights together with Brian about what we're doing together with data streaming and Dish Smart 5G network.
And I'm Brian Mingwasser. Thanks for having me. It's good to be here. I work at Dish Wireless, leading global partnerships. So I get to work with our partners like AWS and Confluent on assembling our network and having an impact in the industry.
Fantastic. So there is a theme that I want all of you to think about as we're going through the presentation today, and that what Confluent and AWS helped Dish build in this ultra-intelligent 5G network is just kind of leaning towards a pattern that will be helpful for any enterprise, right? The challenge is, how do we move data in an AI-driven world, right? At scale and reliably, right? And the key is trusting the connectivity, the wireless connectivity from Dish, trusting the technologies that allow you to move data in and out of the cloud through Confluent technologies, and then ultimately doing interesting things in the cloud, in this case, AWS. So let's begin. So Brian, I'm sure the audience has all heard of 5G. I'm positive all of our phones are connected to 5G right now. But how did Dish build a different type of 5G network, and what makes it smart?
So if you're not familiar with Dish Wireless, we've been on quite a wild ride over the past 3 or 4 years to build a completely new kind of network from scratch. Quite literally 3.5 years ago, we were still at kind of a paper stage. Working with partners, we started building the network a couple of years ago. We were keynote at AWS. And then this year we announced that we completed one of our major milestones, which is to cover 70% of the US population. So in a very short period of time, especially in our industry. And to do that, we had to kind of completely rethink how networks are being built. A fast time frame for this kind of thing would be 10 years. But we only had 3 years. We had hard milestones to meet. Plus, we're living in a different world now than the world in which any other network has ever been built. So we said, of course, we're going to try to use more modern approaches. So a couple of things that were fundamentally different about the way that we built the network. The first is embracing virtualization. So for the first time ever, we separated the telecom software from proprietary hardware, and we ran it in a containerized manner. That gave us huge benefits in terms of speed of deployment, speed of leveraging modern technologies, and also the agility. I remember one day we kind of set up the initial stack, and now we were going to scale it horizontally, and we went like day after day. It was like we're lighting up whole regions, whole sections of the country. It was really, really cool to watch. The second main thing that we did that was different was we embraced a paradigm in telecom called Open RAN. And that's where we require open interfaces between different partners who are providing software or hardware. Of course, that's not really new in the cloud, but it is in the telecom landscape because of the strict requirements. So things like latency, jitter, security, performance. We're with this kind of infrastructure, because it's mission critical, we have to get to 5+9s of reliability. So normally that's a fully integrated stack. We said, no, we want open interfaces. We want to be able to mix and match and take the best of breed radios, software, virtualization layers, so on and so forth. And that's going to give us a lot more adaptability with the way that we use the network, specifically to serve enterprise customers. So that's the last, I would say, layer to this, is that we built this network with the enterprise in mind. So we do have consumer offerings as a company. Boost Wireless, Boost Mobile, and Boost Infinite are brands that are in the marketplace today for US consumers. But for me, that's an internal customer. And This is different than the rest of the industry because usually it was a consumer phone offering first. But now, as we're talking about Gen AI, we're talking about other use cases where the complexion of data has fundamentally changed. It's not phone calls anymore. It's data from sensors, machines, right? We needed to serve those needs in a different way. And we said, well, let's have that as our first and foremost concern. Let's build an enterprise network, or a network of networks, as we call it, turn control over to the enterprise. And all of these pieces coming together in an extremely short period of time, like I said, was a wild ride. And that's what makes us fundamentally different.
That's great. So it sounds like you took some cloud methodologies and applied it to a more traditional technology set, with reliability, scalability, and all those things in mind. Very impressive. So let's talk a bit more about the Dish Wireless data platform. And particularly, I'm very interested about that pillar in the middle.
Yeah, for sure. So one of the benefits that we really wanted to unlock with virtualization and this open interface concept is let's be able to use our data. Let's expose our data to enterprise customers so that they can see how the network is working to serve them. Let's take AI and ML and improve the way that the network is working, rather than having, again, everything be kind of like locked down and hardened, which is the school of thought for operational technologies, right? That's how you achieve, hardened reliability. But we said we know there's so much more potential that could be unlocked if we're optimizing energy usage of radios using ML. Why is that a rules-based system? Clearly, it should be ML.
Right.
Traffic flows, customer behavior, all this kind of stuff. So one of my side comments is that we didn't build a network. We built kind of a cloud.
Yes.
My other side comment is we didn't build a network or a cloud at all. We built a data generation machine. There's extremely rich and valuable data from within the network, the way that all the information is handled. And so we needed a modern data framework in order to take advantage of that. We kind of woke up in the data mesh concept. This was happening right around the same time that became a very popular concept. And I say we woke up in it because I didn't sit down with our team one day and say, hey, should we build a data mesh or not?
Right.
We went so fast and we brought in 60 different partners, with completely different domain expertise and data sets and knowledge and so forth. And so we did have a data mesh. There's no way that you could have a data engineer understand everything, of every different domain. And so we started being very intentional about the way that we organize our data systems and built an architecture. And you can see this this fancy chart here, which is depicting that. And then, we started thinking about, well, what do we need to make that really work in practice? We need access control and governance, obviously. We need metadata and semantics. We need a way of exchanging information between different domains. And, as we look towards the future, exchanging data products from specific domains or, combinations of domains with our future enterprise customers. And so Confluent is really the exchange mechanism in the middle that helps us maintain the kind of governance and exposure that we're looking for, while also having, allowing us to have potentially an unlimited number of domains and enterprise customers that can all kind of transact on data products that are coming from the network.
Fantastic. So as we go through our presentation today, we'll try to show why Confluent is such a good choice for this type of information exchange when you think about scalability, reliability, and then also a unlimited mix of potential data types. So to talk a bit more about Kafka and Confluent and data in motion, Kai, why don't you tell us?
Yeah, absolutely. So after Brian talked about their architecture under the hood, in the end, it's important to understand really what data streaming is, right? Because there are still a lot of misconceptions when people think about this kind of technology. Often the term is, hey, this is a message broker, right? Which is partly true because reality is you send events and messages from data sources to data things. And you can do this with this technology in real time, which in this terms means in milliseconds end to end. And you can do this at extreme scale. So with one cluster with gigabytes per second, right? So you can handle most workloads, what you want to do with that. But data streaming is so much more than that. So the stream in the middle you see in this picture, that's in the end the message broker, but in parallel it's also an event store. And this is fundamental because reality is not everything is real time and not everything will be real time. There are still databases, there are still data warehouses, there are still APIs, and all of them need to communicate. And when now we talk about that data mesh like Brian introduced with different data products, there are sometimes still proprietary systems or they're legacy or they're another software as a service that they partner with and buy, and they need to communicate. And with the data streaming platform, the heart is event-based in real time and scalable. And around there, sometimes you connect to other systems out of the box. Sometimes you use another API, like Python, like Java, like HTTP, whatever you need to connect to that. So that's in the end really a bigger picture of data streaming. And around that, then you can also process the data with the streaming platform. So very often, our customers start in the first use case with building a data pipeline. You connect to data sources like devices, sensors, logs, stream them through the platform, and in the end feed it into a data warehouse or into a data lake. And that's a great and valid use case. But the real value very often comes when you do not just build a pipeline, but when you take the data when it gets in real time and take action on that. Because if you think about that, real-time data beats slow data. That's true for almost every use case. And if you think about that for 10 seconds, think about that in your business. What use case is where later is better for processing data? For creating a report, it's good enough, right? If you use your favorite BI tool and create a report at the end of the day, that's great, and that's sufficient. But for most of these data sets here, no matter if it's technical log data or infrastructure data, or if it's a payment or customer order, real-time data beats slow data. And with the heart of the infrastructure in real-time and scalable, you can always do this and innovate with that. And if you correlate the data in real-time, then you can take the actions for fraud detection, for upselling, for alerting, and so on. And this is really the fundamental piece of what data streaming is in a single platform, end-to-end in real time at scale and reliably. And this is why in the telco space this is used a lot for the core of the infrastructure, to use it as the central nervous system between all these different data products, no matter if it's OSS services or OTT services to the customer or anything else. And this is in a high-level summary to really understand the context before we later also talk about several different use cases where data streaming and 5G infrastructure fits together so well.
Yeah, thank you. It's a lot of insight there. But something that you mentioned, and I think maybe the audience may not be aware of, and if you could just spend a little time on it briefly. What is a data product, and when does data become a product?
Yeah. So that's a great question, right? And it's in the end always important to define these terms because everybody means something different with that. And therefore, from this perspective, a data product is really a decoupled system. And this can be an application, some call it a microservice. But again, this can also be another proprietary product or software service you buy. In the end, it's an independent unit which solves a problem and adds value to that. And then you communicate and share data with other business units or applications. And this is really how it's an independent technology. And not all of them are cutting edge because this is an evolution over time and you can modernize it and keep them in parallel. And this is what the data product is. It's independent, but it also shares data with others. And these different data products can use different technologies. Some are just an API, some are a database. And this freedom of choice and flexibility is how you can evolve the architecture over time.
Excellent. So we talked about Confluent to some extent. We talked about this ultra smart 5G network. But let's talk about more about use cases where we can actually use data stream with this framework and this tech stack. So starting with Kai.
Yeah. So here you see a few examples, right? And we will go into a bit more details on the next slides then. But from the big picture, really think again about the statement, and it's so important. Real-time data beats slow data. And how do you do this for all these kind of use cases you see here? In the end, it's a combination of having the right, reliable, and scalable infrastructure that can provide the data in real time. And also then you need to have the software on top of that so that you can connect the systems, correlate the data, and share it with other information systems. And this combination makes data streaming together with Dish Wireless so powerful to build these kind of use cases across all the different industries. And here you see just a few examples, right? But there's so many more because you will find many others where it's the value if you take the data now instead of later. Because from a business perspective, and this is always how we recommend to start with that, don't just start with technology here and say, yeah, great, we have 5G and we have data streaming, so let's use that. But think the other way around. What's our business problem? How can we add value? And this can be a better customer experience. This can be increasing revenue and upselling. This can be reducing the risk because you have end-to-end observability into the infrastructure. And these kind of challenges, and based on that, then you can build the applications on top of that to solve these kind of problems.
So I know we have slides to cover, quite a few of these, so we're going to dive deeper into each of them. But the first pillar that's very interesting to me, the connected network of networks. Brian, can you talk about that and maybe what some of your customers are doing in that domain?
Yeah, this is the kind of slide where I get really excited because this is why we built the network. Right. I don't know about for all of you, but when I get into my car, my phone maybe half the time connects to my car the way it's supposed to.
Yes.
I don't talk to any enterprise customer that's like, my connectivity is seamless, it's doing exactly what it's supposed to do, it's completely invisible, and I never have any downtime or problems, right? So the reality is, as an industry, we have work to do. And it's only becoming more important, right? The more sophisticated that we're using data now as data products, the more consumers that we have of that, whether that's humans or AI or software, processes, whatever, the more essential it is that we get it right and we make the connectivity invisible. We make it a seamless enabler of whatever the business needs to do rather than a hindrance, which it has been because we never designed it for some of these new purposes. So we really have to rethink it. The network of networks is our concept, our way of saying that the use case, it should be a network that is well suited to the use case. But today, because it's been so difficult and it takes so long to build these networks, we really build one network and try to make it work for all the use cases.
Right.
And that's the lowest common denominator approach that is falling short in a lot of ways. So when we say network of networks, what we mean is that through an exposure of functionality, via an API, you should be able to request the kind of performance from a network, just like you're able to request services from a cloud in order to solve for your particular use case. And we're seeing this in a lot of different verticals. Like I said, this is where I start to get excited because we're seeing the impact now working with our partners and in these verticals to solve the problems that those customers have.
Yeah, see, the more you talk about this, the more you convince me you did build a cloud because everything is API driven, is on demand, is scalable. So, we can have that argument offline another time. So let's talk more about connected data streaming and retail. And I actually want to hear from both of you, but why don't we start with you, Kai? What are you seeing out there in terms of customer use cases in this particular vertical?
Yeah, so as Brian said before, right, there is work to do. And first I want to start with a real world example. So I met a customer a few weeks ago in the US where he told us, well, they have a lot of retail stores in the different cities, and what they're doing at the point of sale, at the end of the day, when they close the store, then they press a button and they do an FTP upload to the cloud because during the day it's not working because the Wi-Fi is not reliable. Because during the day, all the customers are using the Wi-Fi for their own stuff, right? And so this is just the first thing how people start modernizing by optimizing the point of sale as one concrete example where you can directly update the information systems in the backend, no matter if it's in your data center or in your cloud, but connecting the different systems from the edge with your information system in the backend. For example, to know what's the inventory so that you can order new delivery from a truck or similar use cases. This is what hit everybody during the pandemic, right? Where you had use cases like buy online and then pick up in the store. Most retailers didn't know what's going on in the store because it's a batch upload at the end of the day. And this is just one concrete use case. And you can take a look at the entire supply chain in retail. And this means within their own ecosystem, from the warehouses and the retail stores up to the customer, physically in the store or on the mobile app, or even when the retailers talk with the B2B partners that are on the delivery side, right? So this end-to-end is where only with real-time data and knowing what's going on, you can innovate and build applications on top of that. And this is where event streaming can help. And once again, even here, not everything is or will be real-time. And many systems in the backend are not cutting edge and event-based. So this is still an API call, or maybe another system in the backend can only be updated every 10 minutes because it's that old and not built for that. And with data streaming, like in this picture here, you see, when you click a button, for example, from the point of sale and send information to the event streaming platform in your data center or cloud, this event is there in a second, right? But then one consumer might consume that in real time, and that's great to act on that, maybe for fraud detection of a payment. But in parallel, because it's also an event store, other consumers can also consume it later. But what this streaming platform guarantees is the end-to-end data consistency. So many of you, if you're working on the IT side in the backend, might say, we don't need real-time data. And that's true, some systems don't need that. But what I guarantee everyone needs is consistent data. So as soon as you do a query against your system, you need to know that it's accurate data whenever you ask for the data. And with this background, you can do so much innovation and optimization of existing processes. It's not all about building new things. It's about optimizing the existing processes where you can add so much value already. And Brian, I think you have a few customer stories here you can also talk about in retail for that.
Yeah. I love working with retail customers because the problems are so clear. We can all relate to them, right? You go to a retail store, you take the time to drive to a retail store, and you're there with an intent to buy, and you can't find the thing that you want, right? And that's a problem that we can all feel, but it requires a lot of sophistication in the background, right? Of analytics, supply chain, transportation, logistics, in order to make that experience happen. That you walk in and you see what you like, you study it, and then you go to the cash register to pay for it, and you leave. I like what you said, Kai, about the point of sale. And one of the specific things we've been working on is, well, point of sale is kind of like the crux for retail. Consumer walks in, they have money, you have to be able to receive that money from them, right?
Yes.
So it's a mission critical for the retail, it's a mission critical application. So if the Wi-Fi is not working, or let's say you have a lot of consumers and they're all talking on their phone using the Wi-Fi or something, why doesn't the point of sale fall back to cellular?
Right.
If you lose the cellular, why doesn't it fall back to satellite? Because you really should receive that dollar from the customer at all costs, right? Pun intended. But the problem that we've been working on is that point of sale thing does more than receive money from a customer. You also have to update the software. So, you're thinking about, well, I want to maintain this traffic. I want to be able to update things. I want to maintain the software and consistency and security policy for sure of the device. And so again, this comes back to like lowest common denominator network approach doesn't really work. It should be customized for what the thing is trying to do at that time. We can handle the traffic differently if it's an update, in order to make sure that system is just always doing what it's supposed to be doing for the retail. I think the more that we see, the kinds of innovations that I saw some of them on the show floor, where you can analyze the behavior of individuals walking into a store and do those kind of analytics. You can do video analytics for theft detection, other kinds of purposes in the retail. That's adding complexity, and so we want to add that complexity, but we also want to make it easier. And I think if we can do that at the physical layer, and Confluent can help at the data management layer,
right.
And obviously everything ends up in AWS.
Yeah.
Then now we're making it easier and easier to become more sophisticated as a retail and help us in the future.
I really relate to this one. So I worked for a retail company for 4 years, and we used to have these mobile point of sale devices that would drop out of the Wi-Fi. And you know what the fix was? Walk to the other side of the store. Because they didn't fall over, they didn't fall back. They just
turn it off.
They just didn't work, right? So let's talk more about data streaming in automotive. And Brian, why don't we start with you this time?
Yeah, so I already mentioned my favorite problem, which is I get in my car.
Yes.
I paid a lot for this car. I get in my car and my phone doesn't connect to my car. Why is that? I'm going to my car and I have an app on my phone, and it in theory allows me to do things like unlock my car or start the warmer in the winter or something like that, but it never works. Why doesn't it work? And so we're working with an auto manufacturer now to improve this quality of experience. You should be having a relationship with your car, right? So that you can access the car, you can see reports, If there's a maintenance issue with your car, it can alert you about that, and then you can schedule a maintenance or not. And right now we're not quite there. Again, it's been very difficult to establish good connections with a vehicle, with applications or other back-end systems, and to create those kind of experiences. So we're working on that. We saw some interesting examples. Again, there are some interesting ones on the show floor of the way that we want to see connected cars and the car experience become more intelligent. So again, you've got a lot of software on the vehicle now that needs to be updated and maintained. You've got streaming. Maybe the vehicle should be communicating with other things in the city or between the vehicle and your home. And so I'm really excited about this space because this is a perfect application of the network of networks, right? You need, as a vehicle OEM, or even you could take it down to the individual level, you kind of need a network between your house and the apps on your phone and the vehicle. That's a little mini network.
Right.
And you should be able to customize so that you're getting the performance of the application without having to be a network engineer. And like I said, I'm very excited about that in our context of network of networks because there's no way to do it today. If you have one large, first of all, you can't build your own network like this if you're an auto OEM, right. Covering roads and wherever a vehicle is. But if you're able to customize and use our kind of connectivity, and you're able to connect it to other customer networks, at-home Wi-Fi and so forth. Now you stitch together a network, and on top of that network, you can build the kind of experiences that we're going to see in the future.
Very cool. And Kai, I know you work with quite a few of our automotive customers, so I'm sure you have something there.
Yeah, absolutely, because I, of course, see it a little bit more from the software side, but of course, the infrastructure is the foundation, right? Because as Brian said, you need to be able to connect your mobile phone to the car. Then as a vendor or OEM, you need to do the software updates in a reliable way. So there's a lot of challenges with that already, and that's the foundation. But now the great news is on top of that, there is so much innovation which is possible, and I want to give you a concrete example. So when I'm driving in Germany on the Autobahn, right, which is my favorite place, of course, with the car, because I can drive a little bit faster than here, and also the streets are a little bit better. But besides that, the story here is that many of the automotives there, they're also not just building their own use cases from the mobile app, because reality is, while you're driving, right, you are looking at the street until we have self-driving cars, and that takes a few more years. But what you can also do is you can take the data from the other back-end systems again. And back-end system in this case means which I'm the customer of the OEM, and in the back-end system, I have activated some coupons, or they know from my CRM system what other vendors I work with. So they do B2B partnerships with other vendors. And a concrete example in the car is the restaurants, right? If you're in a fast food chain, you know exactly where you are because it's a location-based service. And while I'm driving on the Autobahn in Germany, at some point in time, I might get a push message to my car and to my mobile phone because the backend knows it's lunchtime. And they also know where I am and where I'm heading. And they know this is my favorite fast food chain coming in 10 miles. So they send me an alert and say, dear Kai, if you're hungry right now, here is a fast food chain that your favorite is coming. And even better than that, dear customer, because we love you, and of course they don't, but they tell me because we love you, we give you not just a 10% discount, but for this fast food chain, we give you a 30% discount. And in the back end, to think it even further, and this is reality with some of our retail customers, right? They don't send you this 30% discount because they love you, but they tell you because they also know the inventory in that restaurant and they need to sell some of this food already because the day later they need to throw it away. And this correlation of all the data, this is exactly what data streaming means. It's not just about a communication one-to-one. It's sending the data from the car or mobile app to the back end, correlated with the CRM, with the inventory, and then send context-specific data back at the right time. And this is also important, because if they would just send push notifications every second or minute to me, I wouldn't look at this because it's annoying, I would turn it off. I only want to have this one specific message. And then maybe 5 miles later, a second message. And then I can think about that, right? And this is really the power of how our retail and automotive customers then also work together behind their own industry to innovate, in the end to make the customer happy, but of course also to increase their revenue with that and really innovate and be better than their competitors. And this is one great story, and there's so many more about what you can do in the automotive industry, or then also beyond that when you work with partners like retail or food.
I really look forward to the days when In-N-Out Burger sends me that 40% off. I don't know if it's ever going to happen, but a man can dream. So let's talk about one more set of use cases, and this one is data streaming and manufacturing. So Brian, why don't we start with you?
Yeah, I've been spending a lot of my time on what we call Industry 4.0 kind of applications, because there's kind of a back pressure of lost productivity in this industry, and I think my thesis is that it stems to the network. Because of how important it is for these systems to be operational, there's really a disincentive to change anything like the fundamental infrastructure and the network. An engineering manager at a factory that I know said that he's got so many ideas on how to make a smart factory, but it takes him 6 weeks to make a request to open a port on the network to do something else. And
I used to be the guy fielding that request.
Right? Yeah. So it's crazy. It's creating a ton of friction, right? And we want to completely get rid of that, right? By saying we can bring telco type reliability into operational networks,
right,
but also flexibility to the network.
Yes.
To add new systems, new sensors, new devices without compromising the deterministic nature of control systems that are working on this factory network. We want to be able to bring intelligence, like we have in a telco network, and we were talking earlier. Right. Networks have enormous access to information about the devices, about the traffic flows, but that's not usually exposed because, as consumers, I wouldn't know what to do with that. But for a factory, they can do a lot with that in terms of security and performance and treating the traffic appropriately for the use case. Again, I think bringing it back to everyone's favorite topic these days of AI, right? There's a lot of potential to use AI for worker productivity to improve the throughput in the factory. Kind of canonical example is using video analytics for performance detection, defect detection, and so forth. One of the interesting challenges that we're seeing is how do you scale that up in a network that was designed for SCADA systems only, and now you want to add 200 video streams onto that network, right, and it has to meet certain latency requirements. How are you going to do that? And so these are cases where we're really trying to address the fundamental infrastructure. We know we can't compromise the productivity, so we have to add on kind of layers of connectivity. And again, this becomes a customized network for the factory, but it's not customized like a snowflake that takes network engineers 3 years to design and build. It's something that really should take 3 minutes. It should all be API driven. And as we get better and better at this, it should really be intent based, right? So you don't have to customize it. The network will customize itself, for the need of the applications.
Fantastic. Kai, anything to add?
Yeah, what I want to add, if you take a look at this picture on the left side where you see the connected factory, I wish most of our customers had this setup and capabilities, right, with network slicing and critical SLAs, because reality is most of our customers today, they deploy IT in the factory because they have to implement some smart use cases, right? So condition monitoring, predictive maintenance, most customers do this today in some ways, where they at least measure the temperature, for example. But reality is then they do it on-site in the IT and merge that with the OT there, and then someone has to operate it on-site, which is not a good thing. And this is exactly where manufacturers want to go, so that they still do this in the cloud, or that they do it remote at least, so that they can do all the IT outside of the edge. And this is exactly like you can do this in this picture, but of course the requirement is that you have a reliable network that has the latency that is good enough and the scale that is good enough, and only with that you can even think about these use cases. And once again, just to extend these use cases, that's often how you get started, right? So when you have this connectivity, the first use case often is things like bring visibility, know what's going on in your factory, because you have a reliable network, and then you can monitor your equipment, right? And send a mechanic if something is problematic. This is already huge value if the network allows that, and then the streaming platform correlates the data and sends the alerts. But to extend that then, what our customers are then doing, they are not just building the use case just for the smart factory, but they're using the data from the equipment and PLCs in the factory and correlate it with other data. So one of the great use cases at BMW, for example, they ingest the data from the factories and the equipment into the cloud, and from there, they correlate it with the marketing and sales data. So they improve their entire business processes to increase revenue and make customers happy by getting the data from the factories, knowing what's going on, and combining that with the data from the CRM and the CRP and the ERP system. And these are the capabilities. It's always a journey, of course, but this is this step-by-step approach. Of course, the network is the foundation for that, otherwise it wouldn't make any sense. But based on that, you can really step-by-step innovate by building and adding value with these different use cases. The recommendation is really start small with a first use case that it's relatively simple, like building a dashboard. It's huge value already, you know what's going on. But then you can share this data with other business units. And here it's again the same story, because today, sometimes other business units get the data from the factory, but it takes a week, right? Because sometimes still they copy it on a USB stick and they have to transfer it somewhere manually via human because they are not connected. And in this way, you can improve these processes and then share data with others and ask the business, what do you want to do with the data? And they will tell you, wow, if I get the raw data now in good quality and it's reliable, I can build so many new use cases on top of that. And this is the trends we see in manufacturing. And this is also why then customers can go to use cases like equipment as a service, right? Like software service. No, they do equipment as a service because with this connectivity, they know what's going on and can serve the customer with that. This is only possible if you have both the reliable and latent infrastructure and the streaming platform on top to provide these services in real time.
Fantastic, thank you for that. So as I mentioned, I own the technical partner relationship between AWS and Confluent. So when I have all these AWS logos in front of me, I kind of geek out. So I wanted to talk to you all about some of the Confluent technologies that really complement running things on AWS. And kind of starting there right in the middle, you'll see that there's an Amazon EKS cluster. So imagine a product like Outposts or Local Zones, which I know Dish actually uses Local Zones. We have a Kubernetes operator, and actually just take a step back, we basically have two lines of products. We have a self-managed product called Confluent Platform, and we have Confluent Cloud, which I'm going to talk about quite a bit. Confluent Platform has a Kubernetes operator, which we call Confluent for Kubernetes. It's a very good name, right? And it makes it quite simple to deploy Confluent Platform to any standard Kubernetes offering, including EKS. And EKS is one of the higher level services that exist in Local Zones, Wavelength, and Outposts. Now, moving a little bit to the right, you see cluster linking. So cluster linking is a replication technology for Confluent. It is Confluent proprietary, and it is, in my opinion, the best replication technology across any Kafka service. And then landing into the right, we have a number of different connectivity options for our fully managed offering, which is called Confluent Cloud, which is available in AWS. So you have secure public endpoint, you have private link, you have transit gateway, and you also have VPC peering as options. And then we have something called Connect. Now, Connect allows us to pull data in from other systems. So think mainframes or HDFS or even SFTP server. And really, it kind of is anything you can imagine, including relational databases and beyond. And then we have Sync Connectors. Sync Connectors allows us to take data that's come into Confluent and send it out to another system, like an ISV service like MongoDB Atlas or Snowflake, or AWS native service like Redshift or RDS. And really kind of all of those things to your heart's content, we have connectors that can pretty much connect anything. So that's a really exciting piece of it as well. And then just to kind of call out some of the things we could do that not every other managed data streaming service can do is we can help companies function in a hybrid manner because of that connectivity and because our bread and butter originally, Confluent used to train people how to run Kafka at scale. So we really understand Kafka on premise. And then of course, multi-region. Having a solution that works globally is important for a lot of these use cases as well. So a lot of what we talked about today kind of assumes you know something about Kafka, and we didn't really talk about that. So Kai, why don't you fill in that gap for us?
Yeah, I think that's important, right? Intentionally, we typically talk about use cases first and how to solve problems, but then under the hood, it's a valid question, right? What's actually the technology under the hood? And what we were talking about a lot now with data streaming, the core of that is Apache Kafka, which is a really successful framework. I mean, you see a few stats here, right? Where most of the Fortune 500 companies are using that today in multiple projects, most of them with Confluent. And it's used in really over 100,000 organizations worldwide across all industries. And this is super exciting. And so let's really clarify here again what it is. So just when you get out of this meeting and maybe you still thought, right, Kafka, the next message queue or message broker, right? Because so many people still say that. And to say it in 4 different pillars, what is Apache Kafka? Number one, it's real-time messaging. So that's the obvious part which many people understand, right? And to summarize this again, it's used for extreme scale if you want. like gigabytes per second with a single cluster. But on the other side, it's also for transactional data. Most of our customers have some analytics use cases, but they also integrate with transactional systems for orders, for payments, for fraud, and similar use cases. You can do both with Kafka. Number 2 is the storage. Kafka is an event store. This is a fundamental difference to a traditional message broker because the events are stored in Kafka as long as you want to store them. And this is really the power of why Kafka is so successful, not just for big data, but also for transactional data. Because you can ingest that information once. Some consumer might consume it in real time, like for fraud detection in a payment. But the second consumer actually is a batch ingest because you ingest it into a data lake, and which is more built in batch. And the third one is an API call where you request data from Kafka with HTTP. So it's real-time messaging and storage in a combination. Now, number 3, as Joseph said on the last slide, is connectivity. The first thing typically when you use a message broker, you add an ETL tool or other integration platform, right? Because messaging alone doesn't solve many problems. You need to connect to other systems, both on the source and on the sink side. This is exactly what reflects what you have seen on one of the first slides from Brian and the dish architecture, where the heart is the message broker, but you also need to connect to other systems. This is sometimes with out-of-the-box connectors or with APIs in Java, Python, C++, Go, HTTP, whatever you need to connect to. It's connectivity. And fourth, we talked about this today, is the secret sauce, what I call it often, the stream processing, the data correlation. First, you build pipelines, and that's often the first use case because it's a bit easier. But then, when you also have the data in a streaming platform, and think about correlating that while it's flying through the system. And not just correlating data from one data source, but taking data from a source like a sensor, continuously, high volume, shrink it together and aggregate it, and then at the right moment, whatever the business logic tells you, connect to an SAP system and correlate it with that one specific order ID. And on that action, you send an alert to a customer or to a mechanic or what the use case is. So this together is what Kafka is. And that's what we built the platform around that with Confluent, so that we can provide really the complete solution around that, with security, with governance, with all these capabilities and mission-critical support, so that you can run this in your environment, wherever that is, as Joseph explained. On-prem, in any kind of cloud, in any region, multi-cloud, multi-region, or in hybrid environments. And even at the edge, if you want to deploy it in the factory or retail store. And this is really in summary what we are doing around Apache Kafka. And last but not least, since a year, we are also heavily investing in Apache Flink, which became the de facto standard for stream processing. And so we're also bringing that into our product these days. So if you come here next year, maybe, you might not think about us as the Kafka company anymore, but maybe then you think about us then as the Kafka and Flink company. So let's talk next year about that. And with that, Joseph, you can talk a little bit more about how we also help with the operations of the Kafka cluster.
Thank you so much, Kai. I appreciate that. So just to kind of tie that together, the original our founders of Confluent were the original committers of Apache Kafka. And you'll see why kind of Confluent became a thing in this next slide. Because operating Kafka on your own can be difficult. And I bet a lot of you thought I was going to ask Kai to answer this slide, but guess what? I know stuff too, so I'm going to talk about this one. So I worked at a startup many years ago that started up and never took off, hence why I switched jobs. And our entire stack was Samza and Kafka. And I know I was, this was a startup, so I was one IT guy, of one, DevOps guy. So it used to keep me up at night, making sure that this system would work, because I had to think about things like zookeepers and brokers. And I had to think about the EC2 instances, that we're on the right EC2 instance. Did I pick the right storage volumes, right? Was EBS the right choice? And it became, a difficult thing to do as a single individual with one use case. And when you start to look at some of the scale of Kafka clusters or infrastructures, across the industry, there are companies handling millions of transactions per second through Kafka and beyond that. And what does that take? Well, I'll tell you, it takes a lot. It takes many zookeepers, it takes many instances. So that's why, partnering with a company like Confluent that's kind of solved for all of these problems and has worked with literally tens of thousands of customers and getting over these challenges, which is why we created and we built Confluent Platform, which was the first start, right? Like, let's build tooling into this to make this easier for Joseph to run a cluster. But then the evolution of that, of course, was Confluent Cloud, right? I mean, everyone's building a SaaS solution, and it makes a lot of sense because you can build at scale. You can use the magnitude of learning to build something that is truly cloud native. And that's exactly what Confluent Cloud is. It's a cloud native offering of Apache Kafka. So to just talk a bit more about some of the advantages of Confluent over Kafka. Kai, why don't you start, and then I can kind of close this out.
Yeah, absolutely. I mean, what I talked about a few minutes ago really is that data streaming should be really seen more than just messaging, right? Including data integration, including stream processing, and the event store for the true decoupling of systems. But this is really a complete package together where under the hood there's many things which you actually don't see, right? So how do you store the data? So how we do it under the hood is we provide a tiered storage capability, for example, because we separate compute from storage. It's a cloud-native way. It's an elastic environment, so you can easily scale up and scale down. Especially scaling down is the hard part, but in some peaks you need that, right? And this is exactly like if you think about 5G use cases, like around a stadium of a football game. You need to scale up beforehand, right? And after the game, you need to scale down again. This is this kind of software-defined thinking of both the infrastructure and then the data on top of that, so that it's on the one side scalable, but on the other side it needs to be cost efficient, right? And this is in the end what we provide here, and we deploy that everywhere. So again, in the data center, at the edge, in a manufacturing center or in a retail store, or then very often with a cloud-first approach where our customers do things in cloud whenever it makes sense, but very often and also in hybrid environments. And so this is this flexibility you have, and this is often an evolution over time. And this is the great experience we provide for our customers here. And based on that, Joseph, I think you can explain a little bit better also how this is related to AWS, because this is now also critical, of course. And not most people typically think only about the connectivity piece, but what I see most in the field is more the security concerns, right? So maybe you can especially highlight that a little bit more.
Yeah, absolutely. So that was one of the gaps in Apache Kafka was security, right? How do you securely give access to what could be mission critical data? So with Confluent, we've built things like roles-based access control. We've built access lists. We have open authentication, OAuth integration as well, which is what we see as definitely the future authentication of having independent identity providers from your actual data plane. With the technologies that Confluent has, when I think of cluster linking, when I think of data governance, which we'll talk about in just a bit, when I think of those connectors, it really gives you a pattern to future-proof how you're handling your data. First of all, it can handle pretty much any type of data, right? Most things are JSON inserted, which gives you a lot of flexibility, of course. But let's say you were trying to decide against 3 different services because you're trying to do something new and cool with Gen AI and you want to pick the best and latest and greatest vector database, right? Having your data decoupled, and with our specific technologies, you can theoretically take a use case to 3 different vendors at the same time. And then you have the flexibility of saying, hey, we've decided that this is the technology that we need, and shut those other links down. So you have the security, you have the flexibility, you have Confluent able to meet you wherever your data is, and then of course, do that all in a highly available, scalable manner. So we're going to talk a bit more about a concept that Brian actually touched on initially, and this idea of data meshes, and what that is, and how all of these technologies, the stack that Dish has built, can really help you build a data mesh, and how that might help your enterprise.
Yeah, and just as you've seen this picture, right, and this is the summary of this talk before then we come to the Q&A in a minute, but on this picture now you see really where the data streaming platform, as I explained earlier, you can connect to many different systems. We are connectors, we are APIs. It doesn't matter, right? And you don't know what's coming tomorrow. So a few months ago, most people didn't think about large language models and Gen AI, right? So, but reality is today you need to integrate it because you can add value for so many use cases like customer service. The sweet spot of the streaming platform is that it's open, so you can share data with anything and connect different systems. And in this picture at the bottom, you see a few of different telco infrastructures, right? Intentionally, right, if you take a look into these open source implementations at the telco world, they're also based on top of Kafka. And if you have a good relationship to your favorite ERP or MES vendor, ask them how their next generation technology looks under the hood, right? So many of these systems by themselves use Kafka and share data with others because all of these business units or products have the same requirements, being open but also scalable and reliable. And it's hard. They need to be real-time because real-time data beats slow data. And whatever you build around it, if customer-facing services, network services, this is how the data sharing model then works. And you are ready for the future, whatever that API or protocol is, because you don't know that today. And maybe to conclude this here today, Brian, maybe you can conclude this here, seeing at this picture, right? It's a little bit like your picture in the beginning, of course with other terms, but can you talk again about how this helps them with building your data products? Because I think it's the same for you. You work with 60 partners, you said today, but you don't know what's coming tomorrow, right? And I think this is where you have the infrastructure ready for today, for rolling it out these days, but also for tomorrow.
Yeah, that's the kind of common theme, right?
Right.
We want adaptability for whatever's coming tomorrow. We want it to be real-time capable. We want it to be scalable and performant. And if you have one element of the system that's really holding you back, you're going to be stuck. So everything has to kind of level up in those different capabilities. And then as the system becomes more complex, you naturally end up in a mesh. So if you have, two systems that are talking to each other, fine, you can have kind of like a brittle ETL job, and it's OK. But when you have 60 systems or 600, or you have maybe 6,000 enterprise customers or 6,000 retail stores, now all of a sudden you are in a data mesh. And you have the kind of different layers concept supporting that mesh. So if you physically can't connect at a physical layer to these stores, then they become kind of like orphan nodes. So you need that kind of connectivity. It has to be reliable. It has to be future-proof to add more stores or more types of connectivity in the future. Once you're physically connected, well, now you need to be able to exchange data products. You need, some consumers might need that on a real-time basis. Some might not need it on a real-time basis. But you have to be able to serve that, according to the use case. And that for me, that's the kind of the concept of the data mesh is how do we bring this together into a web that's achieving these kind of gains that we want without being limited by any one component of the stack, whether it's a pipeline or a physical connectivity link or anything else. And when you achieve that, I think that's what a modern data stack looks like, is this mesh of capabilities that's serving the use cases.
That's fantastic. So you have this, really modern infrastructure that Dish built. You have all this great data streaming technology. But one thing I want to add is about data quality, right? So you got all this data flying all around. How do you know that this is the data you want? So we handle that at Confluent with the concept of data contracts. So whether you're talking about a connector or a native consumer producer, everything is basically, things are producing data to Confluent and things are consuming that data. So we've established what's called data contracts through our technology called a schema registry. So the idea is that there's a schema that sets, how many fields the event should have. And what data types those events should be. And I can pass along a schema ID, and then I can enforce that on the broker side to make sure, yes, I'm sending the exact type of data that should be sent, and I'm going to reject things that are bad, so that my consumers get the quality data that they need. We also have advanced feature sets that are around data validation rules that can allow us to actually go beyond just the value of, or the type of the data and the name of the data field and the number of data fields, but actually validating that a social security number in the United States is exactly 9 digits and not alphanumeric, right? And then that is all kind of under the umbrella of what we call data governance, which is a much more advanced set of features that include schema registry and is built around schema registry, but also includes things like data lineage, data discoverability, all these tools that you would want once you fully adopt data streaming and event-driven architecture, and it becomes a central nervous system. So we do have some really cool, it wouldn't be a session without QR codes. So we do have some really interesting links and resources for you to take a look at. There was a webinar, of course, with Kai and Brian, so you can get some more insight about that. We have a resource page specifically for Confluent on AWS, and then our marketplace listing, so you can get started with Confluent Cloud right away. We also give some free credits, so that's great, so take a look at that. We're gonna do a Q&A session right now. We have just over 5 minutes, but also if you haven't already accepted a registration to some party tonight, that is the link for our party at Topgolf tonight, so I'd love to see you there. And with that, we're gonna take some questions.